Behold, Emperor, the vitrium flexile, glass that cannot be broken. Allow me to demonstrate its resilience.
Does anyone else know your secret?
No.
Look closely. At first glance, it's just an old, dusty relic, a jade-green goblet that's seen better days. It looks heavy, cold, and honestly a bit unremarkable. But wait until the light hits it from behind. Did you see that? The green just evaporated. In its place is a crimson glow so intense it looks like the glass is actually bleeding. Is this some kind of ancient sorcery? Or maybe a trick of the eye? Not even close. What you're looking at is a technological monster hiding in plain sight for 1,600 years. Long before we had a name for it, Roman engineers were playing with the very building blocks of reality. They were manipulating matter at a scale so small it wouldn't be discovered by modern science for another millennium and a half. This is the Lycurgus cup. It's the only object of its kind on the planet, and it proves that the Romans didn't just build roads and aqueducts, they mastered nanotechnology. Here's the million-dollar question. How did a civilization without electricity or microscopes manage to infuse glass with particles of silver and gold only 50 nanometers wide? To put that in perspective, that's about 1,000 times smaller than a single grain of salt. At this size, the rules of normal physics start to break down, and something called surface plasmon resonance takes over. Think of these metal particles like guitar strings. When light hits them, the electrons on their surface start to vibrate. They resonate. Now, here's the kicker. Because of their specific size and shape, these particles are tuned to sing in a very specific way. When light hits the cup from the front, the particles scatter the shorter green wavelengths back to your eyes. But when the light comes from behind, the gold particles absorb the blues and greens, leaving only the deep, fiery red to pass through. Was this magic? To a 4th century Roman, maybe. To us, it's a masterclass in quantum optics. But wait, there's a hidden hero in this recipe: antimony. You see, in molten glass, gold and silver usually just dissolve and stay invisible. You need a trigger to force them to clump together into those perfect 50 nanometer spheres. The Romans added antimony as a redox agent, a chemical middleman that forced the metal ions back into their solid, light-bending form. Without this specific chemical handshake, the cup would just be a boring piece of clear glass. Now here's where the mystery turns into a thriller. Was this a stroke of genius or just a lucky mess? Some experts say the levels of gold are so low that it must have been an accident. Maybe some gold leaf fell into a silver melt by mistake. But does that hold up? Not really. The distribution of these particles is so flawless, so uniform, that it's almost impossible to achieve without a deliberate, repeatable process. It feels less like a spill and more like a protocol. There's an old Roman legend about a man who brought unbreakable glass, or vitrium flexible, to Emperor Tiberius. He thought he'd be a hero. Instead, the emperor asked him, "Does anyone else know your secret?" When the man said no, Tiberius had him executed on the spot. Why? Because he was terrified that this new tech would make gold and silver worthless. The Romans knew that disruptive tech could topple an empire. If the protocol for the Lycurgus cup was a state secret, it was a dangerous one. After the 4th century, the protocol just vanished. The trade routes for the key ingredients were cut, the master guilds died out, and the secret was buried under 1,000 years of Dark Age dust. We went from nanotech pioneers back to basic pottery in a few generations. It's a haunting reminder. Technology isn't a one-way street. If you don't protect the knowledge, you lose the future. But as it turns out, the Romans didn't just leave us a pretty cup. They left us a blueprint for the next generation of bio-warfare defense. So, did the secret of the Lycurgus Protocol die in the ashes of the Roman Empire? Not by a long shot. For 1,600 years, this technology sat in a glass case, masquerading as just art. But in 2013, nanotechnology caught up with history. Professor Logan Liu and his team looked at this cup and didn't just see a myth, they saw a blueprint for the future of global biosecurity. They realized that the same physics the Romans used to wow guests at a dinner party could be the key to stopping the next Black Swan event before it even starts. Is this just a recreation? Hardly. It's a revolution. Liu's team created what they call a nano-Lycurgus cup array, or nano-LCA. Imagine a postage stamp covered with 1 billion microscopic wells, each one sprayed with the same silver and gold nanoparticles found in the original cup. But because these nanocups are so sensitive to their environment, their color change isn't just for show, it's a signal. By tweaking the refractive index, basically the optical thickness of the medium inside the cups, they created a sensor that's 100 times more sensitive than any commercial device on the market today. How does it work in the real world? It's simple, elegant, and frankly, a little terrifying. When you drop a liquid, say a sample of water or blood, into the array, the molecules bind to the gold and silver surfaces. This changes the way those surface plasmons vibrate. Mathematically, the shift in the resonance wavelength is captured by the formula, where delta n is the change in the refractive index of the medium. In plain English, the cup tells you exactly what's inside it just by changing color. No expensive lab equipment, no days of waiting for results, just a color shift that you can see with the naked eye or a standard smartphone camera. This is the modern echo. The blood-red warning of the Romans has become a literal alarm system for the 21st century. We're talking about detecting deadly pathogens like HIV, hepatitis, or even SARS-CoV-2 in minutes, not days. In a biosecurity scenario, this tech could identify anthrax spores or botulinum toxins in the air of a crowded subway station before a single person even feels a cough. It's a label-free, low-cost sentinel standing watch over our food, our water, and our very lives. Knowledge isn't a straight line, it's a circle. The Romans touched the monster of nanotechnology, used it to enforce their power, and then let it slip through their fingers as their own empire began to flicker. The Lycurgus cup isn't just a relic, it's a mirror, and what it reflects is us.